All right, so yeah, great to be here. Thanks for having me on. This is a pretty exciting topic, and just a quick intro on myself. So I'm Dan Zaratsian. I'm an AI and ML specialist with Google, and really my primary goal is to build out machine learning solutions for clients, whether it's leveraging our APIs, whether it's tying into our serverless framework, some of our serverless data warehouses like BigQuery, anything that really completes the entire end-to-end machine learning solution for a customer. That's what I focus on. In today's discussion, what I really want to touch on is something that Google rolled out recently, which ties together many, what I believe, very important aspects of machine learning, and we incorporate it into what's called Vertex AI. And so while I'm going to be talking to a lot of Google specific products and the way we approach the end-to-end machine learning lifecycle, but I do want to just keep in mind that a lot of these things are just general best practices for machine learning, no matter kind of where you're executing it, where you are in your journey, in your teams, in your organization. I do want to kind of set the stage there. And then I'll talk about like loading different data sets, how do we train models, how do we deploy those, some of the considerations around ML ops, and some of the new capabilities that are coming out there. All right, so this picture, it's titled "What's Included in Vertex AI." I think it could almost be changed as what is important in an ML infrastructure for data science teams, for analysts, anyone that's kind of working with the data. What are some of these things that are incredibly important? So I'm not going to go through each and every one of these, but I do want to call out a few key things here. So, oh, sorry about that. There are a couple things. So at the top, you see AutoML capability. I believe that in many cases you've heard of AutoML to some extent. A lot of vendors have different capabilities and things that they call AutoML. Basically, it's automated machine learning. It's pushing machine learning closer and closer to low code or no code options for training very sophisticated models that in the past you would have to write very advanced TensorFlow or PyTorch or some other code around. We're trying to democratize that to some extent and really make the cycles much easier so that you train the model and quickly get it deployed as an API endpoint or served up for batch serving. Under that, there are many important aspects of this machine learning lifecycle. So one is just simply making sure that you have the right data labels for the data that you're trying to work with. That's very important. It's becoming even more challenging as we get more sophisticated models and use cases related to images and video and audio and those things, because unless you already have a pipeline in place to collect the labels or whatever your target variable is that you're trying to predict, if you don't have some sort of feedback mechanism or pay people to label it, or can derive it some other way through your internal data sets, actually data labeling is a very manually intensive process. So we have things like that as part of the platform, feature store, training, vector optimization. I'm going to go through some of these as I go through the presentation, but these are some things that I believe are very important. One other thing that I'll just tease right now and then touch on later is containerized machine learning. I believe in this a lot. I think you see it coming more into the forefront with machine learning, that containerized machine learning, both for model training and for model serving or prediction, is very important because it locks in dependencies. It creates a portable platform that you can scale up and deploy across different environments. We'll touch on that a little bit more, but those are some of the exciting areas that Google is working on. So what I have in place here is kind of like a decision tree for what kind of tool should you choose. So first decision point is, do you have your own training data? And if the answer is no, then you leverage pre-trained APIs. That's pretty straightforward. The cool part about that is there's no need to be a data scientist. Basically, you just have to be able to make a REST call. So you take your image or you take your video or audio file, you send it to Google Cloud, and it'll come back and it'll give you the converted audio, or it'll give you labels for the image, or it'll parse the video and give you labels and logos and scene detection, stuff like that. So that's one path. If you do have your own training data, then you go down this path for, well, now do we take a little bit more customized approach for building our model? And that could be through AutoML. So if you want to code, you can, or if you don't want to code, you could go down the AutoML path. But if you do want to code and you have some more sophisticated or advanced requirements, then you go down this custom path. I'll kind of take you through this entire thing and talk a little bit more about it. So one would be the pre-trained APIs. There's several pre-trained APIs, and I work with a lot of use cases, and I'll tell you that almost always we can start with one of these as at least a basis for the machine learning pipeline that we're putting together, assuming the data is in the format we need and the use case requires one of these tools. And so the tools that you're looking at on the screen, they're just like, just like little icons there, but they all mean different things, and they're all different services that Google provides as part of their machine learning APIs. So one of them is this cloud to speech to text and text to speech. I think that one kind of is obvious. It's more for processing audio files or turning text into audio files. And there's a lot of different features as part of that, which I can dive into a little bit further. There's Cloud Vision, which does our image detection, natural language processing, which does text analytics, does sentiment analysis, does some classification, entity extraction, things along those lines. We have Cloud Video Intelligence, and then my go-to webinar panel is, I knew that would happen. Hold on, I'm gonna move this to the side a little bit more. Okay, there we go. Now I can see the whole thing. And then Cloud Translation, which does, translates to different languages. So those are some of the pre-trained models. And what's really nice about this is, and I always kind of encourage customers to use a lot of these things right off the bat if their use case fits it. So let's say that you're trying to analyze an image, or we're capturing these images within a warehouse. We're trying to assess, is there damage to a package, or damage to a piece of equipment, or damage to anything that's kind of coming down that manufacturing line. So best case, or I guess the best situation that you could do is you could actually take this, you could apply this Cloud Vision to your pipeline, and what it's going to do is it's going to tell you, hey, that's a box, hey, that's a car, hey, that's a crack, or whatever. It's going to give you different labels depending on the image. But you're going to quickly run into something, because these are pre-trained models, it might not be as specific as what you need. So let's say that you have your own custom circuit board that you're making, and you're looking for defects within the solder joints or the different capacitors and transistors and things that are on that circuit board. Well, in that case, you're going to have to build maybe a custom model based on images that you've seen in the past where, hey, this is a defect, or this is a something that we want to flag as being damaged or not correctly soldered, or whatever the label is. So we can feed that in as part of AutoML. So all these different capabilities here both have a pre-trained ML model right off the shelf. You can run it, execute, get some results. It's really quick. It's something that you can do basically in, let's say, an hour, even faster if you're good with pulling SDKs, maybe a little bit longer if you're kind of getting started. Now, the AutoML approach, you can do all this with AutoML. You can do custom image detection, custom natural language processing, but you're going to need that training data. So you load it, you let AutoML crank away on it, AutoML goes off, has a model tournament, chooses the model that performs best, and then promotes that as an API and a model that runs in production. We'll get into that a little bit more. Let me talk a little bit about some of these different capabilities. So with the Vision API, this is again the image detection capability within Google. You have couple things. You have object recognition, so it'll set, basically bounding boxes and tags for different objects that it finds. Kind of think about that as a label detection. It does facial sentiment. So are you happy, sad, things like that. It'll detect that. It also detects logos. It does some OCR to extract out text, and it also has detecting inappropriate images, for example. So is it violent, mature, things like that. If you have a need for video processing, this one is very similar, except it's applied to videos. It extracts out labels. It enables video search, so you can kind of have labels and search associated with different tags within that video. We can also do scene detection. We can do object tracking, bounding boxes around different objects within the video, celebrity detection, pose estimation, a lot of great capabilities. And again, these are all out of the box. If you need custom models, I'll get to that, kind of how we implement that in Google. But all these things are right out of the box. You can just take and integrate it into your product with SDKs from Python, Go, Java, whatever language you prefer to work with. Speech is another one. So speech does speech recognition. It'll detect the languages for you. That's one option that it has built in. It also does a lot of noise reduction. That's one of the things that I see being the biggest issue actually within call centers or just mics recordings that customers tend to send in, is that probably one of the biggest issues with any sort of speech, like audio type of analysis, is reducing the noise. So getting rid of the background noise, highlighting the languages that are being spoken, and then converting it to text. And so we have really great capabilities with this. It handles both what we call kind of short audio clips under 60 seconds. That'll be done for you like on the fly. You can kind of wait. Then we have more of an asynchronous type of option for longer running speech audio conversions. So that's going to be anything over 60 seconds. You can just send it to the cloud and then check back periodically for the results to be returned to you. And then we also have a streaming, a real-time streaming conversion that you can leverage. On the natural language processing side, this is pretty straightforward, but the text analytics output that it generates is what I believe is pretty powerful. And I've seen a lot of different text analytics and NLP libraries and different commercial vendors that offer these types of capabilities. And with Google out of the box NLP APIs, you have entity extraction, which will tag for location or people's names or currencies or events, things like that. We do sentiment analysis, and that'll be it can do it at the sentence level, the overall document level, and then you can also kind of do some fancier analysis with part of speech tagging and sentiment on those levels. We support multiple languages, and we also do a lot with the dependency parsers as part of our NLP APIs. And those are all different APIs that you can call. So you don't need to use them all. You can mix and match the results depending on what your use case needs. I always suggest kind of start with that, see what kind of results you get, and then enhance it with AutoML or custom, let's say, TensorFlow or PyTorch or whatever. And lastly, the translation API, it's kind of what we've all seen before from Google, just different language translation capabilities, automatic language detection, continuous updates. I've also worked quite a bit, I don't know if it's on this slide here, but we can also include glossaries. So in many cases, languages need to be converted, but there's certain words and styles of translation that you want to maintain and you want to convert them in a certain way, whether it's historical landmarks or people's names or products. Like certain things need to be translated in a certain way, so you can always inject kind of this custom glossary that'll take, and it'll boost or enhance the translation results. Okay, so I kind of set the stage there. Those are all the ML APIs that are right out of the box. Now let's get into some custom tasks. If you, and in this case, this means you have a data set that you know, hey, Google has these great pre-trained models, but it's not going to work for my use case. So how do I build a custom model that is trained against the data that I have in my database, wherever that is? Now, there's a couple ways that we do this. If you just want to think about it from a really simple 1 through 4 step type option, we create a data set, and I'll show you what that means in a second with some screenshots. Then we train the model, which train the model can mean a bunch of different things. It can be click a button and that'll fire off the AutoML training, or it can actually be, hey, let's run through all this like custom machine learning container that I wrote in TensorFlow. So it can be simple to complex. And then 3, deploy an endpoint. So once you have a model that you like, you want to actually serve it up as an endpoint so that applications can use it, so that you can pass data through it on a scheduled interval or in real time, whatever your use case needs. And then 4 is, I guess, just use it, give predictions. Okay, so there's a couple ways that we do this. One is much of Google Vertex AI. Yeah, and this, for anyone that's familiar with Google, this used to be just called our AI platform or unified AI platform, but now it's called Google Vertex AI. And there are many enhancements that have been done both to the SDK on the back end, but also the front end. So there's 2 ways to interact. One is on the left-hand side, we're showing the user-based GUI-driven interaction. So you can just hop into Google Cloud Console, you can go to Vertex AI, and you can start clicking around and loading your data and then training your model and deploying it, all just by clicking around. It's a great like low code or even no code option that we have. Many customers though too, especially if you happen to be more developer focused or the data science teams are very advanced, or you just want a lot of flexibility, of course we have the programmatic way of interacting with Vertex AI and setting up your models. And this is especially nice for building out a framework that like a templatized framework that auto deploys your models or like checks it, or even watches for when a model needs to be retrained, or when it's drifting from accuracy, or when there's errors or whatever. You can actually fire off this and kind of redeploy your models based on automated fashion. So a lot of use and utility in the SDK option, but depending on skill set and speed to deployment, you might choose the UI option as well, or instead, either or. So the first thing you do is load data sets. So in this case here, we need to select the data set. So what kind of data are we working with? And this varies by your use case. I know I'm kind of generalizing it because we're not working on a specific use case here. But just as I went through in the previous slides, we have the option to analyze images, tabular data, which is the normal data that you're used to working with out of a spreadsheet or a database, or whether it's on-prem or in the cloud. But that's your traditional type of regression or classification type modeling. So you can see that here. It does regression, classification, or forecasting. Then your data type might also be text, or it might be video. So depending on kind of what you're trying to do there, you select the data set, you say what region you want it in, and then you basically upload your training data. Okay. Images, I'm not going to go through all this. I mean, images, we do image classification or object detection. Tabular data, I kind of already told you, is regression, classification, or forecasting. Text, similar to what I showed you before. Video is the same. And again, I'm going through this twice because the first one that I showed you was all pre-trained ML APIs. This one's the custom option, so using your own data. So that's why I kind of want to run through those again. Now, once you upload your data, at this point, you should have your trained data, or I'm sorry, your labeled data in Google Cloud. That means whether that's images, whether that's a CSV, whether that's a billion records that are sitting in BigQuery as part of a SQL style relational database. Whatever that means, you have your data at this point in Google and you're ready to actually train your model. So let's train it. Now there's two options. We're back to this decision tree here. Are you going to write your own code? Right? Do you want the low code option or the custom option? So in this case, here it might depend on your use case. AutoML is always nice for like quick, let's get a model, let's see how it does. At least it gives you a benchmark and it really takes very little effort. So even as long as it fits the use case, I always recommend doing that, because even for a highly skilled data scientist on your team, they can load the data, configure a couple things within the UI, click run, and then wait for that model to train. And while that model is doing its work in Google, they can be coding their like custom TensorFlow or more sophisticated model if they choose to. And then at the end, you compare them and you see what works. But at least you can have like a very sophisticated model very, very fast that you can use to see, can I even beat this? If a TensorFlow model, a PyTorch model, they can't beat what AutoML generated for you, then fine, use AutoML. That's great validation. That means it worked really well. Like put that thing into production. If you need to do some more custom work, or you find that you can do a little bit better by really fine tuning your TensorFlow model, then that's also fine. That's kind of when you go down this right-hand side of the route and you implement that. So a couple of different paths, and I always recommend AutoML first, but definitely it's not like one or the other. All right, so AutoML is one option. I've already touched on quite a bit of this. I don't know if there's much more to say about this, except if it didn't come through, I'll just reiterate one thing that's really nice about AutoML, again, is that it runs a model tournament for you. So it takes your data that you're trying to train or that you're trying to build a model against, and it'll generate several models. It'll grab that model fit statistics, so whether that's accuracy or F1 score or root mean square error, whatever it is, you can actually test that, and it'll do it for you. It basically tests those out. It tries to pick the model that's the best, and that's the one it promotes as the winning model, and that's the one you can deploy into production. All right, so back to the decision tree. Now, if you've gone down this path, you're like, hey, I used some pre-trained APIs. I like what they did for me. Now maybe did a little bit of AutoML. Okay, now I want to do some custom modeling. I need a little bit more for this use case. I want to build a scikit-learn model or TensorFlow or PyTorch. Okay, so in this case, you can come in, and this is where we have some cool options within Google, and I think it all really hinges around containers. We have pre-built deep learning containers that have a set of dependencies already installed for you. Now, certainly you can take that and you can add your own, or you can build your own container from scratch. But what's really nice is, let's say you need Python 3.9 or 3.8, and you need TensorFlow installed, and you also need this other library, and you need OpenCV and whatever. So you can take and you can use our base model that has all of the dependencies you need. And then if you need to add something custom, let's say like OpenCV or another custom Python package or any dependency that's needed for your processing, you can add that to the container that we're using for training. Now, what's important about that, and what's really nice about containers, is that once you have the container for model training, we actually want that to be a similar container for model serving or model prediction, because that way we're locking in complete dependencies from one to the other. One thing that we see that breaks ML pipelines and really production type deployments is data science teams are able to come and build very sophisticated models using, they pop open their Jupyter notebook, they do all this magic in the notebook, and they do all this feature engineering in there, and it's all, let's say it's done on their laptop, or maybe it's done on the cloud, but it's done in their own isolated environment where they install libraries they need. Now we got to push this over, throw it over to production, and now production doesn't have the same version of Python. It doesn't have the same dependencies. It might not even have the same feature engineering steps. So they can probably take that model and deploy it, but when you go to pass data into it, it's going to fail because, hey, I didn't know how to handle those features and I was passing in the wrong features to the model, or maybe I had the wrong versions and like whatever code I was running in to train my model didn't work when I deployed it. So that's kind of why this framework is very important, I think, but also Google is providing a nice guardrails around how we implement it and the best practices. And that's kind of baked into this UI here. Okay. So I guess the way that this works is the models will come in and you can kind of select, you can see here, I went back a slide, but you can see when you train a new model, you define your model. Is it a pre-trained, pre-built model that we're running? Do you have a custom container? You can set model settings. You can define your hyperparameter tuning configuration. You can even set the type of compute that you want it to run on, whether it's a certain size VM, whether you want GPUs, maybe you want TPUs, different options as part of that pipeline. And so when you do that, it'll go off, it'll train your model. We also maintain the model versions. So model versions are automatically logged for you as part of Vertex. And then also when you create an endpoint, so you can see in the screenshot here, it has a little button here called create endpoint. What it's going to do is it's going to take that model that we just built, let's say it's model V1, and I can create an endpoint off of that model. And that endpoint is going to be something that an application uses. So whether it's a web app, whether it's an internal process that runs, a scheduled cron job, like it doesn't matter. Whatever is using that model output, we can actually set up an endpoint, and that thing that's calling it, the client, is going to hit this endpoint, this API endpoint. And what's really neat about this from a deployment standpoint is that we can even do like split traffic between different endpoints. If we want to do A/B testing, if we want to roll out like canary tests and things like that, we're able to really play with the splitting of traffic and see, maybe you want to see like, how does model A perform against model B? Maybe you took different steps to deploy two models. We can split that traffic, or maybe you want to ease traffic into your new model so that it's not as disruptive, or you want to kind of see how customers respond to that new model. That's something that's really nice, and traditionally you would have to handle that by, you know, the ML engineers or the data engineers or the ops team, depending on how your company is structured. Different folks might actually have to build a lot of custom code and a lot of framework around deploying and kind of splitting and monitoring that traffic. So that's something that's built into Vertex. Another thing on notebooks. So I kind of touched a little bit on the dependency side of things earlier, but you know, when you get into notebooks, locking in the dependencies and creating a cloud environment that is collaborative across your entire company or your data science team or who's ever needing access to this data, but also locking in the dependencies is very important. What you can see here in the screenshot here in a moment is there's a drop down right there, new instance, and then you can select Python 2 or Python 3, you could select CUDA, you can select R environment, you could select a TensorFlow environment. You can see there's Rapids, there's Kaggle Python, there's a lot of different options, and these are all pre-built, ready to go Jupyter notebooks. So it has the dependencies already installed for you, and we continually update and maintain those. So they're secure, they're updated with the right libraries, and they're ready to go. All right, yeah, this one's just talking about Git integration. So there's best practices with Git and different change, you know, version control best practices. Now, I guess the last thing I'll touch on here is the ML ops side of things. And really, I would say this is the most advanced part, and I kept it for the end, and I'll finish up here in a couple minutes. But when it comes to ML ops, there's a lot of advancements happening right now on the side of feature store or feature version control. So what happens kind of as you train your model, and how do those features transfer from training to deployment? Continuous monitoring is incredibly important. Like how once we get that model in production, how do we continuously monitor how that model is performing? When we need to kick off a new model, is there model drift? Is there any sort of model bias that's being introduced? And then, something that's not necessarily in here, but also baked as part of this is, explainable AI. Especially as we get into more advanced deep learning models, how do we explain? Well, I guess it's here, but it's not highlighted as part of the ops. But I think that's part of it. Where how do we explain like what this model is doing and what are the important features, and how do we ensure that those aren't introducing bias, even if they're our own bias as a data scientist. And then lastly, the pipeline orchestration. So setting up very controlled pipelines that can be deployed across different environments and also scaled up and scaled down based on these modular containers that are deployed as part of the pipeline. Almost think of it as a bunch of like Lego block container Lego blocks that we piece together, and they can be shared across teams. So maybe I build a really great like feature engineering container that others can use, or maybe I built a really great like model training framework for text analytics that others can use and swap in and out. But ultimately, you want to stitch it together with a pipeline. Google uses Kubeflow pipelines that we've kind of integrated into Vertex AI and tried to make what I think is pretty seamless and transparent behind the scenes. We're trying to make it so it's not so complex when you use Kubeflow and you build out these pipelines, because it is important and there can be a lot to it, especially on the ML ops side. So anyway, I talked about feature store. I just want to touch on that for a moment, and then I think I'm just about done here. So feature store is really great because it has what data scientists run into is they build features and they use them as part of the training, but those features aren't transferred over into the model deployment or model serving side of things. And also, features are generated on a data set at a certain time, right? And a certain set of like values that you're looking at. Typically, there's a time range that you take and you look at your data against, and you want to make sure that the time that you create those features is aligned to the time that you're serving the model. And that if you update the model, you need to update the features, and you need to see, are these features actually introducing bias into my model? Or is there feature skew or well, training skew, but because of the features that have changed as part of my model? A good example would be, well, I don't know. I mean, a lot of you might have examples if you work with ML, but basically where the thing where I see it most evident is when a product, like, let's say it's selling and it either like takes off because of some viral event, or it spikes because of, or it declines because of some event or some reason, right? And so those are very hard changes in the pattern of sales and the pattern of user behavior. And what worked in your model prior to that isn't going to work anymore. And there's new features, the time has changed, and the data itself needs to be retrained. And even maybe new features need to be introduced. So I can get into, actually I go into that flow a lot more when I have more time, but there's a lot of value in this. So feature store essentially version controls your features and tries to lock them in so that there's parity between your model training and your model serving. Okay. So this is it. I'm gonna leave you with this slide, and then we'll open up to questions or any sort of follow-up. So, pipelines are really important. As you're working on your ML teams, I think it's important that maybe you don't have pipelines yet, and that's perfectly fine, but you kind of work towards it. And I think this is one of the end states of a very mature data science team to where you have this entire ML ops flow where you have quick iterations, experimentation up front. You have fast model retraining that automatically gets deployed as an API, whether that's custom or through AutoML. Then when the model's deployed, you have a continuous monitoring loop that's checking your model. And then you have options underlying all of this for, A/B testing, for switching out models, for reverting models back to the previous one, and a full control pipeline that can scale up or down based on your ML needs. So that's probably a lot for some of you. I hope that you got something out of this as part of the talk. And please let me know if there's any questions. I don't know if we have any time right now for questions, but if not, I think they're all being routed to me through email, so we can follow up that way as well.
Excellent talk, Dan. And yeah, we have time for one question. We have here Tim from Lamar State College over in Texas. He had an interesting question about speech API, and does it do any kind of audio balancing? For example, if there's multiple speakers and one of them is very quiet, would it balance out the audio?
Yeah, that's a great question. So first of all, we do have diarization as part of our speech to text. And so, if there are multiple speakers, that is something that we can pick up on. I think the audio balancing part is still something that's been challenging. So sometimes what I've seen is we break out the different channels and analyze those separate so we can amplify some of the softer speakers. So that is an option. There was one other thing I was going to say on that I think is important. But I do think the pre-processing of the audio is very important whenever we're working with any sort of speech to text use case.